Hi, this is the last page of the notes, and if you take a look at it, I'm asking you to find the integral or the antiderivative for each of these. Remember, this is called an indefinite. When you find the antiderivative here, this is called an indefinite integral. I-N-T-E-G-R-A-L. That's what all of these are. And so we'll take a look at this. And here I have a constant, and you can go back in the previous page where I just have a constant, and I think the answer was kx plus c. But I'm going to show you kind of a different way to look at it. I could, if I choose to, write the antiderivative of 3, and notice there's no x, but I could write this as x to the 0 power, because x to the 0 power is the same as 1 dx. And so if I'm going to follow the process, I'm going to add 1 to x, or add 1 to the exponent of x, excuse me, and then I'm going to take 3 and divide it by that 1, which I get 3, and then add my constant. So that's the same as 3x plus c. Now I can take the derivative to check. If I take the derivative of 3x, I get 3, and when I take the derivative of c, I get 0. And 3 plus 0 is 3, and that's my integrand, that stuff that's inside that integral symbol, and dx. Alright, now let's take a look at the next one. I'm going to integrate 5x to the first dx, and so I'm going to write plus c, so I make sure I don't get that wrong, and it's going to be x to the second, and then I'm going to take my coefficient 5 and I'm going to divide it by 2. Now I want to also let you know that's the same as multiplying by 1/2, and 1/2 is the reciprocal of this exponent, because that's what I'm going to look at in this next one. I'm going to rewrite this so I have exponents, just like I did when I took derivatives. And so I'm integrating, I'm going to find the antiderivative of x to the 1/2 dx. And that's going to give me x, here's my plus c, don't forget that. I'm going to add 1 to 1/2, which is 1 1/2, but I want to write it as an improper fraction, so it's going to be 3/2. Now my leading coefficient here is 1, and I could take 1 divided by 3/2, or I could simply take 1 and multiply it by its reciprocal, which is 2/3. Now, I didn't check on number 2, so I'm going to back up and check that. I just thought of that as I was doing this particular problem. I'm going to take 5/2 times 2. I would get 5, which is in my integrand. And then I'm going to subtract 1 from the exponent. I get x to the first, which is in my integrand, which is 5x, and the derivative of c is 0. So I have that integrand when I take the derivative. Likewise, I'm going to do a mental check, and I'm going to take the derivative here. 3/2 times 2/3 is 1. Subtract 1 from 3/2, well, that's taking 3/2 minus 2/2. That gives me a 1/2, and the square root of x is a 1/2, so I get that. Alright, this next one is I have a fraction, so that means I have a negative exponent, x to the negative 2 dx. Again, I'm going to write x plus c. I'm going to get my exponent. I'm going to add 1 to negative 2, and I'm going to get a negative 1. And then I'm going to take this leading coefficient, which is 1, which is 1 right here, and divide it by a negative 1, and it's going to be a negative 1, or a negative x to the negative first plus c, which is the same as a negative 1 over x plus c. Alright, the next one is this particular one, and it's pretty complicated, so I'm going to rewrite it as x squared plus x plus 1 over x to the 1/2 power dx. That is the same as x to the second power over x to the 1/2 plus x to the first over x to the 1/2 plus 1 over x to the 1/2. So they all have that common denominator, x to the 1/2 dx. Well, that's going to give me, if I look at this, when I'm dividing things that are in exponential form and the bases are the same, I subtract the exponents. So I'm going to take 2 minus 1/2. That's going to be x to the 3/2 plus 1 minus 1/2 is x to the 1/2 plus x to the negative 1/2 dx. So that means I'm going to have three things to some power plus c. All right, so I'm going to add 1 to this. So I'm going to add 1 to 3/2, and I'm going to add 2/2 to 3/2. That's going to give me 5/2 multiplied by the reciprocal, which is 2/5. So this term is 2/5 x to the 5/2. I'm going to add 1 to 1/2. That's going to give me 3/2 multiplied by the reciprocal, and I get 2/3. Add 1 to a negative 1/2. That's going to give me 1/2 multiplied by the reciprocal, and I get 2 here. All right, now I'm going to check. I'm going to take the derivative of this and see if I get this inside. 5/2 times 2/5 is 1. Subtract 1 is 3/2. 3/2 times 2/3 is 1. Subtract 1, I get 1/2. 1/2 times 2 is 1. Subtract 1, I get a negative 1/2. The derivative of c is 0. So it checks. All right, this next one is trig. So we're going to see what this looks like. And I can break this up as the sine of x over the cosine of x times 1 over the cosine of x dx. Now this one's going to be in the other page of your notes, and I'm going to rewrite it here as the sine of x over the cosine of x is the tangent of x, and 1 over the cosine of x is the secant of x dx. And so this is the same as the secant of x tangent of x dx. And the derivative of that, or excuse me, the antiderivative of that is the secant of x plus c, because the derivative of secant is secant tangent. Okay? And if you take a look in the previous page where I listed all the formulas for derivatives, I believe I have this one written down. Okay? All right, last problem, number 7. It says, first of all, find a general solution to this derivative. And when I say general solution, what I'm asking for is the antiderivative. So in other words, I want to take the antiderivative of 8x dx. I want to figure out what that is. And then I want to find a particular solution given to that if I'm given this condition. So in other words, when they're asking for a particular solution, what they want you to do is find c. Find the actual value c is. All right? So I know this one, this general one, will have c in it. And I'm going to get x squared. Here's my plus c. So I'm going to take 8 and I'm going to divide it by this number, 2, and I get 4. All right, I'm going to check. 2 times 4 is 8. Subtract 1 from the 2, and I get x. So that right there is my general solution. Now, this can be written as this is a function, this 4x squared plus c. Now I'm going to figure out what that is. Now I know when I plug in 1 in for x, I'm going to get negative 3 as my answer. So here's a negative 3. I'm going to plug in 1 in for x, and I'm going to figure out c. So this is going to be a negative 3 is equal to 1 squared is 1 times 4 is 4. Oops, I meant a negative 3 here, not a negative 2. So this is 4 plus c. So a negative 7 is equal to c. So this is my general solution. My particular solution is going to be 4x squared minus 7. And if I take the derivative of either of these, I'm going to get 8x. All right, and that's how you do that particular problem.